Welcome to Cloud and Clear, the podcast by SADA for innovative business leaders and technology enthusiasts, where we explore how Google Cloud is transforming the industry and what that means to you. Now, here's your host, Miles Ward.
Hi, everybody. My name is Miles Ward. I'm CTO here at SADA Systems, and this is Cloud and Clear. I am super excited to introduce Paul Friedman, who is doing pretty interesting stuff with data at a company called Streetlight Data. Paul, maybe you can introduce yourself.
Sure. I'm Paul Friedman, co-founder and CTO of Streetlight Data. And what we do is we offer transportation data to governments of all sizes, from the small city of San Mateo up to the U.S. Department of Transportation, to help them do urban planning and management of the transportation resources they have much more efficiently. Planning bus routes and highway usage and, traffic light timing and all sorts of uses for our data. And yeah, we are a data as a service company. We've been cloud native now since we started 8 years ago. We've been real happy with Google Cloud and SADA.
Oh, that's awesome. We had talked a bit. You had said you were a founder at the business. What do you see your role, your principal focus? What's critical to your engagement with Streetlight?
Well, Laura and I sort of divide the world in half. If it's technical and technology, it sort of falls under my bailiwick. If it's business or sort of product vision, or anything customer related, it goes to her. So I'm responsible for our overall system architecture, cloud architecture, some of the core algorithms I've coded into the product, some customer projects where they're looking to push the boundaries of what our system can do will end up in my lap, things like that.
Oh, that is super fun.
It is, and no direct reports. I just get to play with the code, play with the cloud, and have a lot of fun.
Oh, that is perfect. Yeah, management is its own operational complexity. There's no doubt of that.
Indeed.
That architecture, right? You designed a system to be able to serve all of these municipalities and government buyers, and those are complicated stakeholders. What kinds of decisions went into the architectural design to accommodate their expectations?
Well, at the end of the day, I mean, we deliver it via SaaS application that is self-service for all of those customers. But underlying that is location data that's streaming in from, app-enabled smartphones. Over 60 million of them are in our network right now in the US and Canada. And we have been processing data over the last several years somewhere in the, maybe 5 to 6 petabyte range. And to do that, you absolutely have to have, more than just a rack of servers. Like, you need to bring some real hardware to bear to do that, both on the inbound data ingest, as well as taking that processed result and serving a result up to the customers efficiently. And that's where Google Cloud comes in.
I used to run a part of the business there that was for solutions architecture. So I've seen just a couple of these kinds of flow charts of you plug this thing into that thing. Maybe walk our audience through what are the major building blocks in the architecture? How do they work together?
Sure. So the data ingest all happens in Google Cloud Storage. That's where we're keeping all of these data files compressed that we buy from our data partners. And they're continuously pushing that data to a 7x24. From there, we have basically sort of, I like to think of it as a blast furnace that takes all that raw data and sort of smelts it into something useful. And that's where we, can do burst workloads up to 10,000 cores at a time.
Oh, yeah.
And then shrink it back down to nothing. So we do our processing monthly. So we'll take a month of that data at a time, just look at that data, clean it up, turn it from raw points into trips, lock it into the real world road network so we can understand, looking at all of these pings off of devices, what was the path on the streets that people were taking and do real-time artificial intelligence on it. So we've got a machine learning system that does what we call mode inferencing, where we look at a point and can tell, assign probabilities of, is he walking, biking, in a car, on a bus, on a train, in an airplane, etc. And that inferencing engine runs at about 20 to 30,000 inferences per second in the Google Cloud. And that's before we started using their TPU engine. We think we can jack that even higher and save some cost off of that too. Google's been making some changes. They're still in early alpha to beta that could really help us, because we're not just doing a simple image process that they're optimized for. We're doing sort of more data inferencing.
Got it.
From there, the data feeds into a really large distributed relational database. It's running around 160, 200 terabytes. It's on a 16-way sharded Postgres system with geospatial extensions added onto that. That's floating at around 300 cores right now. And that's the core of the system that then computes the results to the questions that our customers are asking.
So that ends up feeling like not only the sort of transactions of recording the individual requests from customers and keeping track of of what it is that you owe them back in terms of response, but also doing the analytical processing, or is that kind of
well, it's there's three stages. There's the web application tier. Mm-hmm. There's a data services tier that sort of keeps track of the request. And then this is just a straight relational database of our reference data. It's really more follows a data warehouse pattern.
Sure.
Where they're doing, analytics on, show me all the trips that went from this block in my city to that block in the city by the time of day. What were all the roads they took in between? How does that break down? What were their modes of travel? Or analyze my whole county all at once. And I want to see the flows broken up by the hour of the day, day of week. How people are moving, and it lets them do, predictions so that they can look at things like, okay, well, what if I have to close this road due to, damage or something? If I need to detour, or if there's an accident, what will the ripple out impact be? Where will traffic naturally divert to?
Okay. What other alternatives? There's a lot of different ways of storing a big block of data and grinding away at it. Bunch of first party, third party services of all sorts. Walk me through kind of the decision making and the analysis to pick that.
Sure. Well, when we first built out this architecture was about 6 years ago. Mm-hmm. And back then the trend was everything, no SQL map reduce, no SQL map reduce.
Sure.
Store everything in text files and just throw a lot of cores at it and let each core chew on a couple text files.
Yep.
Fundamentally, our data is really just 5 fields. We get device ID, timestamp, latitude, longitude, and then maybe what operating system the device has. And that's it. Mm-hmm. So we're very, very thin, but really tall. I mean, petabytes of that stuff.
Yep.
So having built in geospatial intelligence, like at the lowest layers of our infrastructure, is really core. And none of the NoSQL vendors had that. Also, the inefficiencies of file parsing and file processing, as opposed to keeping things more natively like relational databases do, landed us on PostGIS, which is Postgres with the GIS extensions. We benchmarked it. It was by far and away the most compute efficient and fastest solution. So we developed, on top of that, a sharded architecture and something that we call map reduce built on that architecture, where we will map and distribute the queries out, do an initial reduction on each of the shards, pull the semi-reduced results back together to a middle tier, do a final reduce, and then push the result back to the customer.
Okay.
It's much more compute efficient than using like a Hadoop or something like that.
I would imagine because of the kind of inbuilt, because you're doing like spherical lookups and sort of distance ranging and Yeah. No, having all of those functions kind of
Shortest paths contained inside Polygon. You name a spatial operation, we use it somewhere.
Got it. Oh, that's pretty fascinating. You manage you manage the Postgres end to end. You have a relationship with one of the management.
We do it
vendors?
all ourselves.
Yeah.
Ourselves because it's so tweaked and so custom for our install. I mean,
Yeah.
I've liked where Amazon and Google have been going in terms of managed instances, but it's not for the scale. It's not for, the extensions that we load into it, and it is core to our business. And so by us doing that, we've had to build out a lot of the operational processes like backup and disaster recovery using the cloud architecture. And I've got to say, Thor and our ops team are just ridiculously amazing. Plugging into a lot of that, especially using the SAN technology that cloud offerings give you. The latest benchmark is we can do a full DR, like shoot all the databases in the head, bring it up in a new region in under 4 hours.
Yeah.
And that's like 160, 200 terabyte database.
Yeah.
And like, that's,
yeah, it's serious. It's one of the,
it's amazing. Like if you read any of Google's internal networking papers on their internal mesh architecture and cross switch architecture, you can do some amazing data movement things when you like really start spinning it up.
Yeah. I built a system at AWS a long time ago that saturated the east-west networking for a little while as we moved President Obama's infrastructure from one side of the planet to the other. And so, definitely am sensitive to, the realities of the physical cabling between these places.
Yep.
And with Google at, whatever, it's almost a petabyte and a half a second bisectional, which is a multiple of the public internet. It's like, oh, that is actually hugely useful in some of these corner cases that can really mess people up.
It is. And so it lets us burst to these, incredible, speeds on it.
Yeah. I wonder, like, I think we've definitely been in this sort of cycle where, because the public clouds have all these managed services, you get analysts and pundits, crying out, the DBA job is over and we're not going to need those ever. And you're like, but
not even true.
Real world, like there are so
well,
many
it just moves up though. In the old days when hard drives were 5-10 megabytes and then 5-10, 50, and zeros keep getting added on. The definition of big just keeps moving.
Yeah.
So now, if you've got like a sub 1 terabyte database running on SQL Server, totally go for a managed solution. But I remember in 1992 when Oracle first had, 1,000 TPS and a terabyte database, that was exotic technology.
Yeah.
Now, let somebody else manage it. So, there are a lot of mom and pop DBAs, I think, whose jobs have been in jeopardy for a while.
Sure.
But it's just moving up. But then again, also, people are storing more data because you can, and it's cheaper too. Yeah,
no, I think there's definitely spots where that set of skills, as long as you're on board with the autodidact, self-education stuff that's just so required, I think a lot of people imagine like, oh, the technology is changing. And so I'll be put out of a job and I'll have to go back to flipping pancakes or having fun some other way. And you're like, no, like you have 99% of what's required to take the very next step. And
exactly.
The very next step after that, like this is all being built by people who are trying to take those steps up the ladder. Like,
just don't stand still. That's how you get left behind.
That's right. What has Streetlight Data done internally, maybe around education and skills development and stuff like that?
Sure. So we set up Streetlight EDU, which is a department just around internal education. It's got a staff of 2 full-time employees that literally is just internal education. I'd say probably 3/4 of it is focused on educating our fields, so sales engineers, SDRs, et cetera, on product capabilities as they come out, technical capabilities, but as well as, people come up with new algorithms or new innovations, pushing those out, recording those for future use. There's always a new training course popping up every 2 weeks.
Awesome. Yeah, no, we're just in the middle in our teams of pulling, kind of a second revision of that whole program together.
Yeah, it helps onboarding and scale too.
Yeah.
Somebody new jumps in, oh my God, start here, spend 3 days taking these classes and get up to speed on the company and what we do.
Yeah. What, personally maybe, or with, maybe as a part of the team that you're working with, what do you think are the next skills that you want to capture? Where do you think there's the biggest opportunity in the markets that you're working in and the technologies that you're plugged into?
For us, it's something we've been calling data engineers.
Mm-hmm.
There's a lot of data scientists that, like to live in the clouds and just, play in Jupyter notebooks and that type of thing.
Sure.
And that's good. If you work at a Procter and Gamble or GE or something, I'm sure there's a lot of jobs for that. But somebody who's got that sort of hard to find mashup of good SQL, good numeric, good statistical skills, as well as knowledgeable on, current machine learning models and training, so that you can, feed data in at scale, train something at scale, and then deploy something at scale, trying to find that sort of practical balance of somebody who has some combination, but at least a little piece of each of those three skill sets. We're really focusing our hiring.
Yeah, one of my buddies has coined the phrase data logistics. And I'm there's a lot of that where you've got to plumb these things between different service, you're kind of one end of the spectrum, being sort of purpose built and cloud native. And, there's the integration is likely new customers, new partners, or things like that. Lots of companies, they have to, go back into the morass of their existing gear and try to figure out how to pluck the goodness out of it.
Oh yeah, ETL is just exploding. Now it's the new next generation cloud native ETLs that, where all of that is going.
Yeah. Yeah. No, we've been doing, my team ran a project together with the folks at Ocado. They're a e-tailer in the UK, and they had spent, an incredible amount of time and energy rebuilding a bunch of their ETLs in Spark. And Spark is rad. Spark is a giant move forward from Informatica or, some gnarly blah. But we were able to train them up on data flow and showed them kind of what, the reduction in boilerplate and just sort of simpler, terser definitions for all this stuff.
Yep. Flow computing.
Yeah. It's just incredible how much more straightforward thinking through these kinds of ETL problems is in that context. And their performance advantage was just massive. Something like, what they had been working on for 6 months, they kind of rebuilt in 2 or 3 days. So, any spots where, that's a pretty miraculous result and something that, sticks with us. We're like, oh, that's a huge conversion. Any places where cloud has been a little miraculous for Streetlight?
Like I said, being able to burst 10,000 cores on demand and then throw them away 10 minutes later or, 10 hours later, that is something you could not have done anywhere else with any other technology set. So that once a month, we've got, a couple billion trips of data coming off of those devices, and we want to map them on to the real physical roads, so that the point wasn't here, it was here, it was here, it was here, it was here. Well, he took a left, he took a right, he sped up, he slowed down, on those roads, and pulling them out of all those GPS circles. It was just not possible earlier. Same thing that real-time inferencing, you could have a trained up, machine learning model, but throw some cores at it, just get it buzz sawing away through your data, and then you're done. So I don't want to keep paying for those things.
The burst ability is totally incredible. I remember I was going through describing the architecture that we used to live stream the video from the Mars rover when the Opportunity rover landed, which was just an incredible moment. And of course, that whole infrastructure didn't exist. And then we turned it all on and ran this live stream and then shut it all back down. And doing this presentation and the Prezo coordinators, the folks that were running this conference, had really aggressively encouraged like feisty, confrontational, aggressive Twitter engagement to really try and like get a constructive dialogue and some, let's be real and, dig in on, and so there were a bunch of people who were like, this is a big complicated topology. And I don't know, maybe I could have done it this way. Or there was a bunch of hypotheticals about how they could have approached. The next presenter was describing what it would take to build a data center and what the current like best practices and correct components on all the rest. The feedback for this guy, the one that I remember, is just, he was like, this developer who was sitting in the front row was, I would rather write a compiler than do all of this stuff. Exactly. Right? Which is true, right? Like it's one thing to think about, the cost profile of all that, fine, right? Like you got to figure out somebody who's going to loan you $20 million in gear to be able to have 10,000 cores laying around, or maybe it's 2 million.
And then hand them back.
Yeah.
And then like, after they've depreciated or whatever.
It's great. Like, oh my gosh.
Yeah. But I just use them, here at our company about 2 days a month.
Well,
but I use them every month.
Yeah.
So I can't, who's going to like build the data center, destroy it, build it, destroy it every month? It's a new pattern. Yeah.
Plus, this is now a couple of weeks ago. I'm interested in if you've done a run already. I think for the entirety of my history working in public cloud, it's been an all Intel game. I mean, there was Amazon kind of jumped up and had these Graviton processors where they were going to do ARM. And then Google now did this announcement where they have
the AMD cores,
the N2Ds. Yeah.
Yeah.
Have you done any runs with those?
We just shifted that 10,000 plus core load to N2s this last month. It's now in production there. I'm a little annoyed at having to now I want to pilot it on another chipset and let's see what the cost savings will be.
Sure.
It did speed up by about 30%. The cost only went up about 10%, just like they advertised. So life is good. Probably in a month or two we'll do that, but also I've got to wait until they say there's enough of those cores there that I can, because if I only get 1,000 cores, I can't use it.
Yeah, capacity remains the monster, whether it's yours or somebody else's, for sure.
Yeah, but when they roll out a new chip, like once it's really, they've decided to stick with it and they buy a ton of it, then we test it out. I'm the sort of curmudgeonly CTO that believes my job is to remove technology risk from my business. We have plenty of business risk. Like maybe nobody wants the product. Maybe they want a different product. Maybe it takes 2 years to sell it. Maybe they won't pay enough. That's fine. Businesses should have that risk. They shouldn't have technology risk. The stuff should just work.
Yeah.
So
I'll
wait till the new cores they've decided to stick with them and pump them out. I'll always play with these things, but we will never deploy until it's way late in the game.
Well,
I'm so glad I skipped Hadoop, for instance. Yeah. We had investors telling us your CTO's an idiot. We're not investing in him because you didn't build it on Hadoop. Oh, Hadoop didn't last. I mean, I think Spark could stick, but I'd still like to see a couple more years on it before I'm going to move my pipelines over.
Sure.
I want all the tooling, all the infrastructure, ideally seeing sort of 5+ years behind anything, so that it's just brain dead reliable and, let's live with the business risk.
Yeah, no, I mean, my startup, Hadoop literally saved our business. But then again, that was in 2007.
Yeah,
right. And
exactly.
The number of options that were available was substantially smaller, and that Googlers internally look at these kinds of problems and then immediately prompt their autocomplete on their computer to respond instead of them. But it's an easy thing for them to go, Google hasn't used MapReduce in a long time. We've deleted all those clusters. We actually deleted the thing that came after MapReduce, and now everything's Dremel, and you should be all on BigQuery. But you're right to look at what we see from a lot of customers is, it's deep compatibility and all of the rich features, right? I mean, I remember when it was kind of a big hubbub that all of a sudden MongoDB had gotten some GIS extensions, and we're like, oh, whoa, like they're going to be for real all of a sudden. Like, okay, cool.
Yeah.
Like,
same thing with BigQuery. They just pushed out. We've been in the alpha of BQGIS since it came out.
Right on.
That's probably the next piece of technology that I would bring in.
Yeah.
It's still the tooling. It's not just the database, but I want to see the tooling around it. Do the ETL tools all support it natively? Are there the JDBC plugins for everything, natively everywhere and robust? Is it all fully built out? How do I get sort of predictable response out of it? How do I cost effectively manage it? They just pushed out, pre-purchased and reserved pods in BigQuery. So how, can I play that? How much would it save me over my Postgres instance of those 300 cores? What would new spend versus old spend look like?
Yep.
Prefer response time on my physical SSDs versus them pulling from cloud storage. Am I still going to get the same thing? Same fast answers.
Yeah, these questions are intensely near and dear to my heart. I spent a bunch of cycles pushing on the benchmarking platform, PerfKit Benchmarker, open source toolkit for running these, and then also am the one who stood up together with Ben Traynor and Urs Holtzley the TCO calculators for Google Cloud that then eventually had to get pulled offline. So those, like, it is one of the things that I'm proud of at SADA, where we do get to interact with customers and help them think through the business dynamics, the cost and performance, availability and risk avoidance and all of that in the technology decisions that they make. But I know that there's just a huge amount of, effectively tooling, right? Like, we need better pre-built existing analyses of some of the interrelationships so that smart folks like us can just be working on the gnarly bits that are maybe not as well understood, your specific queries on your specific subset of data, right? Like, that stuff that's going to make a difference in your decision.
Yeah, I need the debugger for BigQuery GI so I can look at the query plans.
Yeah.
And figure out why this query is fast and that one is slow. It's all of that next level of tooling and maturity that I need to see in a platform.
Yep. Yeah, no. And I think what's been great for us as we've now interacted even more with the broader set of product management, I mean, there's definitely an urge on the Google side to continue to take some of the sort of rocket science that sits inside the primary business and polish it up for shipping to the world. But one of the things that's so hard about those kinds of approaches is often all of the enablement and support structures around those were designed for these native Google tools that sit internally that aren't being shipped. And so it's like, well, cool. Like, you talk to that database over gRPC, which is really a weird way to do it in the rest of the world. Like, how are you making it so I can plug into the applications I've already built or the components? So
yeah, exactly. Their load balancer that they pushed out in Google Cloud is amazing.
Oh yeah.
That is like an infinitely auto-scaling load balancer that lives up to its name. Yeah, but in the earlier days of it, it was buggy. It would only work on some protocols on certain ports. You would have a hard time understanding when it was going to scale your instances, when it wasn't. I can see how they would have been happy with it internally, but it took them another year or so to polish it and get it out there. But we have always had one of those for a couple of years now, feeding those 10,000 cores, just tons and tons of data and transactions. but it was a little bumpy at the beginning.
Yeah, it's one of the things that I really liked, right? I mean, seeing high scale operations at AWS, right? I mean, I hung out and did Netflix planning sessions and spent a bunch of cycles with the people at Splunk as they built up that back end, and the indexing systems for Dropbox, right? Big infrastructures. And there were, immensely potent and high performance systems being driven around by like 1 and 2 people and for whom the operational characteristics were absolutely dependent on how long their lunch was and stuff. So, Google, I think in a bunch of spots took a little longer to ship individual features or to get individual capabilities ready to go. But
they also started later too.
Sure. I mean, that's kind of a given piece. But when they resolved an individual problem, if they said like, we have gotten, this bit completely ready to go, I found very few moments where they were just totally wrong and it wasn't ready at all.
Yes. And that's probably the biggest reason that we selected Google over Amazon. So we were initially on Rackspace for 2 years. Google didn't exist. Amazon was too expensive, and worse, in the earlier days, Amazon charged for disk I/O.
Sure.
And so running a really large database at scale, if I'm getting charged by the IOP, it would just sink my business.
Sure.
So that's why we're at Rackspace, as the only alternative, really, at the end of the day, using the iron there. They fell apart, as you know, but Google built things the way I liked to see them built. They built the cool tech, they built out the infrastructure stuff really, really solid, and left, the high level pieces in the stack, to Amazon. That, they focus on giving you a good load balancer, giving you an amazing, SAN infrastructure. And that's what I wanted.
Yeah. I remember the Spotify folks, their comment was, you don't have all the buttons, but the ones you have, they're weapons grade.
Basically.
So that'd be fun.
Yeah. Well, and they have the right ones,
Yeah. Yeah. No. And I mean, I think it's, we're in a market where, the companies that I work with and spend most cycles with, this is not like a corner of their company, and over here they have this weird little experiment. This is the center line, the beating heart of businesses. If these
100% of our infrastructure is at Google Cloud. I mean, I've got a rack of VMs here that we do a little bit of local prototyping on.
Sure.
But I'm keeping on there, I think, 1/160th of 1 month's worth of data, to play with. And that's a big deal. It's on a local SAN, and it's on like $10,000 worth of hardware.
Sure. Exactly right.
That we purchased. 1/160th of 1 month is what we prototype with here. And then you push it to the cloud to play with the real thing.
Yeah. Well, I really appreciate you taking the cycles with us. I hope that our audience will take as much away from it, at least as I did. I thought this was super interesting. Any last questions for me or other bits that you wanted to say to our audience? I'm super excited about how this all went.
No, I've just loved working with SADA, loved working with Google and the Google Cloud products that they've pushed out, and it has made our business possible.
No, that's awesome. Well, Paul, thank you so much.
Thank you. Great talking with you.
Groovy.
Thank you for listening to Cloud and Clear. Check the show notes for links to this week's topics. And don't forget to connect with us on Twitter @Cloud and Clear and our website, sada.com. Be sure to rate and review the show on your favorite podcast app.